The next topic what we are going to discuss, matter of some 1 hour session, AVL, AVL trees. So what is mean by AVL trees? A very simple example for this AVL tree. See, AVL tree means it is a kind of self-balancing tree. So it is a kind of self-balancing tree. It is a kind of self-balancing self-balancing tree. So self-balancing tree means what? So there are some problems are there in binary search tree. To overcome those problems only, we are moving to these AVL trees. What problems are there? I will explain, don't worry. So it is internally binary search tree only. Internally it is binary search tree only. And sir, what is the advantage means? Let me take one simple example so that you can get clarity. See, I want to create one binary search tree for the elements called 10, 20 and 30. I want to insert some elements called 10, 20, 30. So total how many nodes are there? We have 3 nodes we need to create. We have to create 3 nodes. So how it will be? Sir, first step, I am going to insert first 30. Okay, or let me take first 10 I am inserting. Then where 20 will come? So this side 20 will come. Where 30 is going to come? It will come here. This is one step. When if we are inserting 10, 20 and then 30. Suppose consider I want to insert, so 10 followed by 30 followed by 20, like that we have. Then your root node is a 10 and the right subtree is nothing but 30, and for 30 left subtree will become 20, like that. So this is nothing but two combinations what we have. So what about remaining? Sir, sometimes you can insert 20, 10, 30 also, or you can insert so 20, 30, 10, like this also. In such cases what will happen? So first 20, so 10 will become what? Left child for this 20. 30 will become what? Right child. Okay, fine. Now here also, so 20, so right child will become 30, left child will become 10. Then what about next? Sir, 30, 10, 20 we can take, or so 30, 20, 10 also we can take. So if you take 30, 10, 20, what will happen? 30 will come here. So 10 will come here, less than this one, and 20 will come here. What about this one? 30. So 20 is lesser than this, 10 is lesser than. You can see, if you have total 3 nodes are there, how many trees we are constructing? Anyone count and tell me how many trees we are constructing? 6. So the number of binary search trees that you are going to get is 3 factorial, which is nothing but what? 6. If you have 4, then how many combinations you will get? 24 trees we can construct. So if you change that order, but among these, which is recommended? First one, second one, third one, fourth one, fifth one, sixth one, which is recommended? Can I
Third,
can I
fourth.
say these two?
Hmm.
Why? Because uniquely the nodes are distributed. Can I say it is a something like complete binary tree? Clear?
Yes.
So
Yes.
how we are deciding? Based on height only, right? Am I right?
Yes.
That height is going to play an important role in AVL tree. So what is AVL tree means? There is one term with name balance factor. In short form, it is called as BF. Balance factor of an AVL tree. Balance factor of an AVL tree is always -1 or 0 plus 1. For every node, what should be the balance factor? It is always -1, 0 plus 1. So coming to the formula for balance factor, how to calculate balance factor? It is nothing but, so height of left subtree, height of left subtree minus, we have to take, so height of right subtree, like that we can take. So this height of left subtree minus height of right subtree determinant must be less than 2, either 0 or 1. I used mod, that's why minus. If the balance factor is equal to 0, or if the balance factor is equal to -1, or if the balance factor is equal to +1, then it is called as balanced tree. For this, there are number of trees are there, like red black tree, AVL tree. There are n number of trees are there, but here we are going to discuss AVL tree. So in any order you can insert. If height is not properly maintained, then what we are going to do? We will perform some kind of rotations. We are going to do some kind of rotations. So based on that rotation, normal tree will be converted into AVL tree. Up to this introduction, whatever I covered, do you have any queries?
No, sir.
There's one query I have.
Yes,
Like,
please, sir.
yeah, so what is, like, what if we make a tree as a balanced tree,
Hmm, hmm.
then what additional advantage we will achieve? Like, if even if it is, uh, like, like what add-on it brings?
Suppose if you take these kind of trees, see this one you are seeing, right?
Mm-hmm.
Suppose assume we have 10 elements are there. These 10 elements are arranged like this means, if I want to search for the last element, number of comparisons will be increased, correct?
Mm-hmm. Okay.
But if you convert like this, number of comparisons will be reduced.
Yeah,
In
but
this
like,
case, how many comparisons? Roughly 3 for searching for element 30.
mm-hmm.
In this case, what will happen? 1 and 2.
Okay.
That is one factor. And even it is not looking good, right? You can imagine how difficult it is. So if
Yeah,
it is in the perfect style, I mean complete binary tree, then easy to perform any operation.
okay. Yeah, but since it is in hierarchy, so like traversing is anyway, like, if I have to insert anything, or if I have to find anything,
Hmm.
then uh, like it is still
See, insertion and deletion is not that much important a factor, sir.
okay.
So always we will see a data structure, whatever service it is offering. Our main motto of going for binary search trees is what? One is to maintain hierarchical manner. Second one is what? Why that hierarchy? Because if any problem is coming, easily we can rectify. Because less number of comparisons will be there. You can directly involve with some activities, and we can bypass some negligible cases. Our intention is that one only, right?
Yes.
So still how much betterment you can do. See, if I reduce the height of the tree, automatically searching operation will become efficient.
Okay. Okay, sir.
See, insertion is not a problem. Suppose if I have 100 elements also, insertion will be done only one time.
Yes.
So suppose I added one university database is there, I added one student record. It is a one time activity. But getting the results from that website is n number of times, right?
Right. Right, sir.
That is the reason, sir. Beyond that, nothing.
Okay. Yeah, so it
Got
means
it?
like optimization of search operations.
Yes, exactly.
Okay. Thanks.
Right, sir. So now, how to do that? For that, there are different rotations will be there. For doing this, there are different rotations are there. I will explain. What are the rotations that we have here is, remember, commonly we have two rotations. One is left rotation and the second one is right rotation. We have to do these rotations to convert your binary search tree into AVL tree. So for this, there are four cases are there. The first case is LL case. In LL case, we will always do right rotation, remember. And there is one more case is there with the name RR. In RR case, we will do always left rotation. I will show you first these two, then I will explain the remaining things. Maybe suitable examples are there or not, I don't know. Just very at a top level. Anyway, I will take example and I will demonstrate at a very top level regarding this diagram, how you can convert, I will show you. Observe carefully. I can say this last diagram, whatever we have, is something like LL rotation. So what we are doing here, right rotation. So right rotation means what? Like this we have to rotate. If I rotate, 20 will become parent node, 10 will become left child, 30 will become right child. Like that we will get. Sir, how to do that rotation? That part I will take care later. Now RR case is what? This one only, right? Because right node, right subtree. Now what we have to do? Left rotation. If you do left rotation, 20 will become left root node and 10 will become left child. So 30 will become right child, like that. So do you have any doubt in these two cases?
Rotation, like, I'm not clear, like how rotation.
Diagram is clear, right? Just
Yes.
I'm explaining visually.
Mhm.
If visualization is clear, how it is going to work programmatically, I will show you. Don't worry.
No, rotating, like, for example, LL rotation. So how
Hmm.
it is rotating in the right side, like.
That you need to remember. See, 10 is the left child
Mhm.
of 20. 20 is the left child of 30. So which rotation it will come? LL case. In LL case, which rotation you have to do? Right rotation. This is the thumb formula.
Okay, okay.
Okay.
Mhm.
Now, what will be the next case? LR case is there. So LR case and RL case. In LR case, what we have to do is first left rotation and then right rotation. RL first right rotation and then left rotation. So I will explain with the help of diagram, then you may get some clarity. 20 in this case, 20 is the left child. Am I right?
Yes.
So for 30, 30 is the right child. Am I right?
Yes.
Sorry, everyone clear? Huh?
Yes, sir.
So it is what rotation? It is RL. If it is RL, what we have to do? First we have to do which rotation?
Right.
Right rotation. That means we have to shift like that. So this tree will become, so 10, 20, 30. After this which rotation? Left. So again it will become what? 20 and then 10 and then 30. Coming to this one, 20 is the right child, 10 is the left child. What notation it is? LR. In LR, what is the first rotation? Left. Towards left, can you please move? Only these two. So 30 will be the root, 20 is left child, 10 is right child. After that, right rotation. If you do, then what will happen? So 20 will become root, 10 is the left child, 30 is the right child. Now you can see whatever trees that we have, 1, so 2, 3, 4, 5, all are same, right? Like
Mhm.
that, if anywhere imbalancing is occurring, but how to calculate that balance factor and all, I will show you with example, then only you will get clarity. I hope the visually what is happening, you got very clear clarity. Any questions?
No, sir.
Clear?
Uh, Sir, one doubt, like this rotating to left or rotating right, like
Hmm.
I like it. I'm not able to understand. Like it is happening about which node? So suppose, for example, in the LR example, you first said it should be left first, left rotation. So left about which node? So 20 or 10 will rotate left.
Which diagram you are asking? Count
So
one,
yeah,
two, three, four, five.
fifth one, sir, fifth one.
1, 2, 3, 4, fifth one. See,
Yes.
in the fifth one, the least
LR
node,
is clear, sir.
20,
Like
right?
this is
LR
an
is clear, right?
yeah, LR case it is that we identify, but how rotation is happening, sir, that is not clear.
Which rotation for LR? First one, left rotation.
Mm-hmm.
Towards left, we have to move. Just observe. If you move left, what will happen? 20 will become 10. Like this, we are rotating.
Correct.
With respect to which node?
Okay,
This
20.
node. I will show you because you are confused with by using which node we have to do all these activities.
Yes, sir.
So
Like
there is one balance factor. Wherever balance factor is mismatching, there we have to do that, because at here it will become very difficult for you to understand. In the coding, I will explain.
okay.
Diagrammatically and theoretically clear, right?
Yes.
So because next example is also similar to this. Once if you got that example, then directly we can go for the program. Clear?
Okay.
Right. So now I will take one example, sir. What is the example is? Can you please insert? Can you please insert the objects like 40, 20, 10, 25, 30, 22, 50? Like that, I want to insert some objects. Let us see how we are going to do this. It is AVL tree, right? So first we have to insert 40. So the node 40 will be inserted here. Now we need to calculate balance factor for this. What is the balance factor? Tell me, left side how many nodes are there? 0. Right side how many nodes are there? 0. 0 minus 0, 0 is the balance factor for this node. Clear?
Yes.
Now we have to insert 20. Tell me, 20 will come to the left or right?
Left.
Left to 40. So after adding a node, again you have to update the balance factor for every node. For 20, left side 0, right side 0, the balance factor will become 0. For 40, left side 1, right side 0. So 1 minus 0. Can I say the balance factor is 1? Correct?
Yes. Plus one.
Is it a AVL tree or not? Yes, right. Next,
Yes.
I want to insert a 10. If you insert a 10, what will happen? So here 10 will come, right?
Mm-hmm. Yeah.
What is the balance factor for this? 0. What is the balance factor for 20?
Plus one.
1 minus 0 plus 1. What is the balance factor for 40?
Plus two.
Plus 2. It is not balanced, right?
Yes.
Where it is balanced? Not balanced. 40. So who is the left child of 40? Because we have to see from
Hello,
where
sir.
the balance factor is not matching.
Hello, sir.
Yes.
Sir, 20 beside plus 1, how will it come in, sir?
20.
20 beside plus 1, you can write now.
This one is left child height.
Left child height, sir.
So how to calculate balance factor? Height of the left subtree minus height of the right subtree.
Okay, okay.
Okay. Right. So this one is which child? Can I say it is left child and it is left child? Correct? Is it which rotation? LL. LL means what? What we have to do?
Right.
Right
Right
rotation, right?
rotation.
Yes.
If you do right rotation, as of now there is no rules. 20 will become parent. So left child will be there as it is. Right child will become here. Now tell me, what is the balance factor for 10? Left child, no notes. Right child, no notes. 0 minus 0. For 40, 0. 1 minus 1, 0. Now perfectly it is AVL tree. Am I right, friends?
Yes.
Yes.
Now what we have to do? We have to insert one more node 25. It is greater than 20 but less than 40. Here 25 is going to come. So after adding any node, the total tree balance factor you have to update. So for 25 it is 0. For 40 1 minus 0 1. For 10 0. For 20 1 minus 2. That means what? Minus 1. Is it a balanced tree or not? Yes, right.
Yes.
Now what we have to do? We have to insert 30. So greater than 20, less than 40, greater than 25. Correct?
Sir, how 20 is minus 1 there?
Madam, height of the left subtree 1.
Acha, 1 minus 2. Yeah,
Height
got
of the right subtree 2.
it. Mm-hmm.
Now after adding 30, what we need to do? We have to update the balance factor. So it is 0. 0 minus 1. It is minus 1. 2 minus 0. It is nothing but a plus 2. And this one is 0. And this one is 1 minus 3, which is nothing but minus 2. Correct?
Mm.
Sir, clear up to this?
Sir, once I can explain that once.
Sir, left side, how many edges are there?
Who's
Left side.
one
One.
once?
Minus right side, how many edges are there? 3.
3.
Maximum. Minus 2.
Okay.
If you take 40, left side, how many edges are there?
2.
2. Right side, 0. That's
Right
right.
side 0.
Clear? Now, if you see the diagram, here the balance factor is not coming. Can I say it is a left child, it is a right child? Which rotation? LR. Correct?
Yes, sir.
So first what we have to do? We have to do left rotation. If you do left rotation, 20 will be there. For the 20, you will get a 10. And for opposite for that, we will get 40. And for 40, 30 will become root node and then 25. After doing this left rotation, what we have to do? We have to do right rotation. If you do right rotation, then what will happen? In the place of 40, so we will get 30, and here you will get 40, and in the place of this 30, so we are going to get which one? 25. Got it? Correct? Now calculate the balance factor.
Again. 40 left, right.
This one, okay?
No, sir, that 40, 30, 20. This one is okay. It is,
From
you're doing
this,
first right.
then we have to do left rotation.
Hmm.
If you do left rotation, what will happen? 30 will become parent, right? Because with respect to this one, we are rotating.
Mm-hmm.
30 will become parent. So 25 is left child, 40 is the right child. Got it?
Hmm.
Now, what is the balance factor? 0, 0. This one, 0. This one, 0. 1
Zero.
minus 2 minus 1. Is it
Hmm.
AVL tree or not?
Yes.
Yes.
There is no problem. Right?
Sir, one
Yes.
Now,
like here the balance factor is getting disturbed only in the first diagram 20 and 40 minus 2 plus 2. So rotation should happen only for these two nodes, right?
yeah, rotation. See, wherever the balance factor, when you are inserting any node, if it is disturbing the balance factor, with respect to the inserted node, we have to perform the rotations. So after doing rotation, again you have to calculate balance factor for every node.
Okay, okay,
Suppose if there is any imbalancing is occurring, again you have to do the rotation. It is a never-ending process.
okay, got it.
Now which node we have to insert? 22. Where it will come? Left side of 25, right?
Yes,
So after adding this, is the balance factor is going to be disturbed or not?
yes,
So what we need to do? We have to rewrite the balance factor for every node. Am I right?
yes,
Now update. For 22 it is 0. So 1 minus
0 plus 1. For 25 it is plus 1.
for 25 it is plus 1. For 40 it is 0. 2 minus 1, 1. And for 10 it is 0. For 20 it will become 1 minus 3 minus 2. Correct?
Yes,
So it is not balanced, right?
yes, sir, no balance.
By inserting which node we got this problem? By inserting 22. Correct?
Mm-hmm.
So is this a 22 is which child? Left child. Correct?
Mm-hmm.
For which one?
25.
25. Sir, is it correct? I think somewhere. Yeah. So this is a left child and this one is also left child. Correct?
Mm-hmm.
Which
Yes.
rotation we have to do?
Uh,
Right rotation. Correct?
yes, sir.
Right rotation. If you do right rotation, 20 will be there, left child 10, then right child 30, then I think right child will become 25. Correct? 25 will become parent. Am I right? If you move towards right, then 22 will become left child, and for this 30 will become right child, and for that 40 will become right child. Sir, is it correct rotation?
Uh,
We did left rotation with respect to these three nodes.
why we included 30 in that, sir?
Sir, we have to see three nodes.
Like three
Which is
nodes.
the node inserted?
22 and
From
20
that,
here.
this is nothing but the problem created, right?
Mm-hmm. Yes.
So this is nothing but a parent. Sorry, this is nothing but a child. This is nothing but a parent. This is nothing but a grandparent. From this, you have to do the rotation.
Okay, okay.
See this, if you see the example program, then you will get clarity, sir. Okay.
Mm-hmm. Yes, sir.
Now again, the balance factor is not matched. If you want, you can check. It is 0, 0 minus 1 minus 1. This is 0. So 0 minus 2, 1 minus 2 will become minus 1. And this one is 0, 1 minus 3 minus 2. Again, the problem came, right?
Yes.
Where the problem came? In
20.
which node? 20. So can I consider because of this one only, right? Is it left child? And this one is right child, correct? Huh? Now with respect to these three nodes, we have to rotation. Got it?
Now, since 22 is already inserted, again we are considering that, but problem is happening at 20. Why again we are taking 22, sir?
Because by inserting 22 only the problem came, right?
Okay, okay.
You need to consider that as the child. From that you need to do the modifications.
Till grandparent.
Till grandparent. Suppose again after doing this also, if you are getting problem, from where we have to do? From 22 only, because shuffling is happening, right, sir?
Got it, sir.
Now what we have to do? Yeah, RL rotation. So first, which one we have to do for RL?
First,
Right.
Hmm?
Right rotation.
First we have to do for RL. For RL, first we have to do right rotation.
Yes.
Can I say right rotation means like this, correct? Huh? So I will reconstruct that tree. Now I will change the color also. Now observe. So if you rotate, can I say 20? Which one will become parent? 25. Huh? Okay. So first 20 will be there. For that 22. For that 25. For that 30. For that 40. And here 10. Am I right, sir?
why 20 did not rotate, sir? It is still at its same position.
Because which rotation I am doing here?
Right.
Right.
Rotation.
This will come here and this will go.
Okay. Oh, okay. But 20.
Now after, we will see. After that, which rotation we have to apply? After R, L, right? So with respect to these nodes, again we are going to do
right rotation.
So if I do right rotation, what will happen?
So this time which all note, like 22, 20 and 25.
These three, right?
Okay. So
Now which one will become root node?
22 will become the root node.
22 now.
Yes. Right
Yes.
left rotations.
So 22 and then left child is 20. So left child is 10. Right child will become 25. So again 30, again 40, correct? Huh?
Yes.
Then
again we have to calculate the balance factor.
for this 0, for this 1, for this 0, for this -1, for this
-2.
-2. Again here problem is coming, right?
Yes. 22 become -1.
So here the problem is coming. So here if I make 25 as a root node, what will happen? Let us see. Anyway, how to do that we will see in the program. Then what will happen? 20 will become left child. So 22 will become right child. 10 is already there. And 30 will be there. So after that 40 will be there. Now check the balance factor. 0 minus 1. So 0, 0, 0, 2 minus 2, 0. Correct? But how that rotation is happening in the program, you will get clarity. Same example I will explain in the program. Sir, clear up to this? Because there are some formulas are there based on that these rotations are happening. I will show you that clearly, don't worry. So visualization wise, please see. Clear?
Yes.
Now which node we have to insert?
50.
So where it will come? Here it will come, right?
Yes.
But again balance factor will mismatch, it will rotate. If I rotate here, 40 will become here, you will get 40, and here you will get 30, and here you will get 50. Balance factors is matched for everyone. Sir, clear up to this? But don't worry how these rotations are happening. Again, I will explain with example. Don't worry at all. Clear up to this?
Yes.
Clear.
Sir, whatever you told, it is okay diagrammatically, but internally what is happening, I need to understand. Don't worry, there is a time for that. But how it is working, I want to show you by taking one animation so that you will get more clarity. I will take one animation so that you will get one clarity. So what is that animation here is, observe carefully. So here I am taking Avl tree animation or visualization online. There are multiple websites are there. Better to take this one maybe. Now observe. First, which element we inserted? I think so 40. If I insert 40, it will be added like this. Sir, visually is it displaying clear?
Yes.
Now the next element is I am inserting 20. Observe what will happen. Just I will reduce the speed. Now see that 20 is going to be compared here and it will attach here. Got it? On the top of the node we have 1, 2. Those are not balance factors. So now I want to insert a 10. Where it will come? It will compare with root. Coming to the left side, it will compare with 20. It is attached here. So it will update the balance factor, but balance factor is not matched. So it is doing some rotation. Got it?
Yes, sir.
Now, what is the next node that we are supposed to insert? 25. Now see, it is compared with root node greater. It is compared with 40 less than. So it will attach here and it will check balance factor. I think it is perfectly all right. Then we have to insert 30. It is compared with root node greater, compared with 40 lesser, compared with 25 greater. It will be added here. After that, reconstruction must be required. Like that it is shuffling. Now, what is the next node? 22. Compared with 20, compared with 30, compared with 25, it is less than 25. So it came here. It is checking for balance factor. It is not matched. So it is reconstructing. Two rotations are there. It is at a time performing. Then last node 50. It will be compared with 25, then compared with 30, then compared with 40, it will be added here. Height is not adjusted, so it is doing some rotation here like that. So this is nothing but what we have. Sir, understood what is happening there visually? We got the same tree only. Clear, friends? Please confirm.
Yes, sir.
Yes, go through this whenever you have a time. Sir, if you are clear with everything, I will start implementing the program for this AVL tree. Can I start? Please confirm.
Yes.
So for AVL tree, I will do some small modification. Node structure is the same, but for every node, in addition to data, I am taking one more field called HT. What is a HT? Height. Height of the every node by default, it is 1. By default, height of every node is nothing but what? 1. Like that I am considering. Do you have any doubt in the node class?
No.
Then after this, so I am taking the class name as AVL tree. Static node root. Here also AVL tree. Root node is initially null. Then, sir, some special methods are needed like a static integer height of the node. If you are passing any node, this method is going to return. If node is equal to null, if node is equal to null, what is the height? 0, correct? Huh? Otherwise, I am returning so node dot height like that I am taking. So anyway, I will update that height. Don't worry. Then one more method, static integer get a balance. For any node, if you want to get a balance, so if node is equal to null, I am going to return 0. Otherwise, what we have to do? Height of left subtree minus height of right subtree. We have to find out. Any queries on these two methods?
No, sir.
Clear? Huh? Clear up to this? Please confirm.
Yes.
Now I am doing insert operation. Insert operation, as I said, it is the same like binary search tree. Whatever operation we are doing, same like a binary search tree. Correct, sir? Is there any new rule? No, right? Clear? Array, tell me, clear?
Yes.
If node is equal to null, we are creating a new node. Else, sir, I am doing this conditional check here itself. Else, the data which you are trying to insert is less than node dot data. So I will take this statement. So again, else if the data which is greater than node dot data, I am doing this insert operation. Else, what is the meaning of this? I am going to return the node as it is without disturbing. Can I say it is for duplicates? Of course, duplicates are not allowed. It is for duplicates code. Up to this, any questions? Please confirm.
No.
Now, sir, after inserting, can I say we have to calculate or we have to adjust balance for each and every node and we have to return the root node? Am I right? We have to adjust the height, right? Correct, sir?
Yes.
Now, what is the first node that we inserted? 40, right? 40 is inserted. Now what will happen? We have to adjust the height. Tell me. So how to adjust the height? We have a formula. The node which you inserted dot height is equal to, that is ht is equal to. So how you can take 1 plus math dot max of, so height of node dot left, comma, so height of node dot right. So what is the left node height for 40? 0. Right node height 0. Max is 0 and this height is nothing but 1. Clear, friends? Clear?
Yes.
Yes.
Now there are 4 cases I have to write. What are the 4 cases? If balance factor BF, balance factor. How to get balance factor? Balance factor is equal to, can I call get balance factor of the node? What it will return? What is the balance factor for this node? I will mark in red color. Height of left subtree minus height of right subtree. Can I say 0?
Yes.
We are not required to do anything. Correct? When we have to change? If the balance factor is less than minus 1, we have to do some modification. If the balance factor is greater than 1, we have to do some modification. Otherwise, as it is. Am I right, friends?
Yes, sir. Right.
Code I will write later. Getting the concept. So after 40, the next node which I want to insert, listen carefully. The next node which I want to insert is 20. So observe the flow. 20 will come. Is node is equal to null? No. So is the data, that is 20, is it less than 40? Yes, right? Correct.
Yes.
Then where it will insert?
Left.
Left.
Left of 25. Left of 40.
Left of 40. Can I say here it will attach? Got it? Right?
Yes.
But remember, this if condition is satisfied. That means these two statements never come. Right?
Right.
Now these two lines compulsory executes. What is the height of the node? What is the height of the node? 1 plus
40.
height of the left subtree, comma height of the right subtree, 0, 0. This node height is 1. Correct? What is the balance factor of this node?
0.
0.
0. Return the node. To which it will return?
40.
Huh?
The column.
Can I say here?
Okay. Yes, sir.
Sir, please understand. Correct?
Mhm.
After assignment, again this condition will be evaluated. Correct?
But we first else if it executes, why?
Hmm.
Okay, else if
Hmm.
is first else if has executed. So
Hmm.
if this okay.
Anyway, it won't satisfy. But chances are there, right? Okay, forget about that. Can I say this one again it will execute?
Yes, yes, sir.
Yes. Have you observed? Now what is the node? 40, right? Because we assigned to node dot left.
Yes.
Now, what is the height of this tree? This one will update, right? What is the height of the tree? 1 plus height of the left subtree, 1, comma 0. 1, 1 plus 1, 2. Correct?
Yes.
Then what about balance factor?
+1.
So 1 minus 0 plus 1. These two conditions are not satisfied. Simply it will return to the root. Now there is no issue, right? Clear?
Yes.
What is the next one? Which node we have to insert now? The next node is 10, sir. Where it will come? Here. Am I right?
Yes.
What is the height? 1. What is this node height?
2.
2. What is this node height? 3.
3.
What is the balance factor of this one? 0. What is the balance factor for this one?
+1.
What is the balance factor for this one?
+2.
Here it is not matched, right? So is the balance factor is greater than 1, correct?
Yes.
Now, in addition to this, we have to write one more condition. Sir, the value which you inserted, that means the data which you inserted, is it greater than the data which you inserted, is it greater than node dot left dot data? What is the data you inserted, sir? 10, right? Is it greater than? Node means what? This node only, right? For this only we updated latestly, correct? What is its left node? 20. What about the data? 20. Is the condition is true or false?
False.
False. So, like this, we have to take one more condition. What is that condition? If a balance factor is greater than 1 and the data what you have inserted, it is less than. This one is true, right? What is the meaning of this? Sir, can I say the left node is available as a left child, LL case? Am I right? If this situation happen, it is LL case. The data which we inserted 10, it is less than node 40, its left child 20, the node which we inserted here. Got it?
Yes.
Yes.
In such a case, which rotation we have to do? Array, tell me. Which rotation we have to do?
Right rotation.
Right.
Return right rotation with respect to which node?
10 and 20.
Node. That's all. Node means what? 40.
40. Yeah.
Clear?
Yes.
This is the first chance. So now forget about the diagram. Can I say if the balance factor is less than -1 and the data which you are inserting, is it greater than node dot right dot data, means it comes for RR case. For RR case, which rotation we have to do? Left rotation. Am I right? So what is the opposite? The balance factor is greater than 1 and the data is greater than. Got it? Then which rotation we have to do? LR case. In LR case, what is the first rotation?
Left.
Node dot left is equal to. So we have to call which rotation? Left rotation with respect to the node. Am I right?
No.
With respect to the right node. Then return which rotation we have to apply now? Right rotation with respect to the node. This is one case. What is this case? LR. There is last case. What is that case? What is the last case? If a balance factor is less than -1, if balance factor is less than -1 and the data is less than left dot data, then it will become RL case. In RL case, node dot right is equal to, first we have to do right rotation with respect to node dot left, sorry, node dot right only. So after that, we need to take left rotation. Just I am explaining only the code snippet. I will execute this and I will show you how it is going to work programmatically. Do you have any doubt in this? But don't worry. Once if you see the example, you will get clarity. But pattern wise, clear, right? Correct?
Yes.
Yeah, yes, sir.
Can I say the same operation we have to do? The same operation we have to do even after deletion also. Because if you delete any node, definitely there will be some modification. Correct, sir?
Yes.
If you do deleting, then what will happen? Definitely some modification will be there. Am I right?
Yes.
So after that, you have to do balancing or not?
We have to do balancing.
This is the code for that. Same code only, right? Got it? So delete leaf nodes, this and all I am removing, print range, print root to leaf, print path, etc. etc. And you here also finding minimum, maximum, search, all these operations I am removing. That's all. Except that, nothing, sir. Are you clear outline? Please confirm. I think we have to write two more functions. Anyone tell me what are those two functions?
Left and right rotations.
So static node, what is a method name? Right rotation with respect to some node y. And static node left rotation with respect to some node x. So left rotation, right rotation, only two methods. But how many times we are calling, that depends. Sir, clear up to this? If you are clear, then I will take the same example, whatever I covered, one by one, and I will insert and I will show you. Clear? In the yesterday's session, we started AVL trees, like what is mean by AVL tree, how we can able to create this AVL tree, from binary search tree, how we are going to create this AVL tree. Suppose if any problem is coming, how we are going to adjust the height of the tree. For that, if any problem is coming, there are some rotations are there by using which we can able to solve. What are the rotations that we have? L L case, L R case, R L case, R R case, like that we have. And for doing that, we have left rotation and right rotations are there. Based on this, we are going to adjust the balances. And even I covered these with the help of example program. We started implementing the program of AVL tree. So we inserted some elements also, right? So now we have implemented node class, and we have seen how AVL tree class is constructed. For that, we defined a constructor and a method to calculate the height of the tree. Then even the balance factor, how you can able to get the balance factor, and in order, how you can able to calculate in order. This is common for everything, right? And even the level order we implemented, and utility function for insert node, because whatever function that we have in binary search tree, same function only. And after this, overloaded version also we covered. Up to this, whatever we covered is same on binary search tree. What new things will be there? Adjusting the balance. So whenever you are adding a new node, for that node, we are updating the height. At the same time, how to calculate balance factor. If the balance factor is greater than 1 means again two cases. So what are those two cases? If the data which you are trying to insert, is it less than the node? If it is greater than the node. If it is less than the node, already left child, left rotation, left side. So already left side, right side, like that. If it is less than -1, there are two cases. One is greater than, one is less than. For this, yesterday I already covered. We have to use left right rotation for LL case, left rotation for RR case, and if it is LR case, with respect to the right node, we have to do left rotation and assign to left side and again right rotation. All these things, if you see with some example, you'll get clarity. One example is sufficient for you to better understand. So now delete node. Sir, for delete node also almost same activity. Okay, so only the methods that we are left over here is right rotation method, left rotation method. We have to demonstrate how it is going to work. Okay, sir, if everyone clear, then again I will explain this LR case, RL case. Based on that, we will move to the program. Clear up to this? Please confirm. Clear?
Clear, sir.
No. So just I wanted to draw LL case in deep. LL case means what? Already there is a node called A. For this node, there is one child called B. And for this, there is one more child called C. Sir, is this is the structure for LL notation or not? Please confirm. But we have not seen the child classes for this. That is the problem. So left node of C, right node of C. For B already left is there. So right node for B. And for A also right subtree will be there. Definitely there may be a chance of having nodes like this, right? So now what will happen? If you do the rotation, so which one will become parent? B. I already covered yesterday. So if B is the parent, who is the children for this? C is nothing but a left child. As usual, there is no disturbance for CL and CR. Observe carefully. Who will become right side? A. So for right side tree, AR there is no disturbance. Only disturbance is with respect to this BR. In original diagram, BR is present inside left subtree, but now BR will move to the left subtree of A. Like that, after rotation, it will be there. We know with respect to ABC, but regarding its children, we never. Sir, you understood the point? Please confirm, madam. Clear?
Yes, sir.
Now, same thing if you take for RR. So that means what? There is a parent node is there called A. For that, there is one child is there called B. And for this, there is one child called C. As usual for C, so child class left node, child class right node will be there. And for this B, left node will be there. And for this A, left node will be there. So now what we have to do? Sir, if you rotate, what will happen? B will become your parent. Then A is nothing but left child. Okay, so C is nothing but right child. For C, CL and then CR will be there. And for A, AL will be there and that BL will come here. So this is nothing but LL rotation, RR rotation. Clear up to this?
Yes, sir.
Now, so we have to do the same operation for RL and then, RL and then LR. Let me take for RL. Let me take for RL. So what will be the node structure? The node structure is nothing but, so first there will be a node called A. For this, AL will become left child and B will become right child. And for B, so for B, C will be nothing but child class. And for C, as usual, CL will be there. So CR will be there. And for here, BR will be there. So this is RL notation, because this is the right child and this is the left child. RL notation. So in RL notation, what we have to do? First, we have to do right rotation. If you do right rotation, so what will be the tree diagram? First, root node A will be there. So next, C will become its parent. Then B will be there. Already I covered this. So for B, there is BR. No need to disturb that. Now what will become this left side? So can I say, so CR will become left side, and here CR, sorry, CL and CR, and for this AL will be as it is available, like that, first rotation. So after this right rotation, what is the next rotation? Left rotation. If you do left rotation, so which one will become parent here? C will become root node. Then for that A is the left child and for that B is the right child. So for B, CR as it is available. So BR as it is available. And for A, AL will be as it is. But this CL will come to the right side to left side. These things, while constructing the formula, you people will get confusion. That's why I am explaining here itself. Are you clear with RL case?
Yes, sir.
Now LR case. What is this LR case? See, there is a parent called A, and for that one left child is there called as a B, and for B, so there is one left child called as a C. So for A, AR will be there, and for B, so BL will be there, and for C, CL will be there, and CR will be there. So what is the first rotation that we have to do? Left rotation we have to do. If you do left rotation, so what will happen? Your A will become parent and your C will become parent and your B will become parent, like that. Next AR is there, okay, and here, so CR will come and here CL will come and here BL. This is after left rotation. Then what we have to do? We have to do right rotation. If you do right rotation, so who will become parent? C is going to become parent. Then, so B will become left child. So next for this AR is as it is available. So then what will happen? That CR will come here. CR is CL. Please confirm which one will come here. CR only, right? Then here BL is already available. So then here CL will come. Like this we have to do. Clear? Everyone please confirm. Clear? So now we will see how to construct the tree. Okay. Next we will see how we are going to get the outputs. So which tree we are implementing now? AVL tree. So tree is equal to new AVL tree. Like this I am taking. Let us first insert 10. Slowly we will insert one by one and we will see the level order. When you insert one, what will happen? There is no disturbance, right? Successfully the program is going to run, and since we inserted with only one element, so there won't be any disturbance. Let us see. Java C test.java I am taking. You can see there are some errors. Okay, because these methods are expecting some return type, right? That's why, okay, as of now, for my convenient purpose, I will put it as a node void. Line number 130, 137. Okay, in the previous case, sorry, 1 second. Sir, here it is having multiple lines, right? Compulsory we have to enclose within brackets. And I think this bracket is not required. Yeah. Okay, no problem. First we will implement those methods, then we will update. Okay. Sir, can I go for program example? Please confirm everyone.
Yes, sir.
Tell me, what is the first node that we have to insert here is nothing but what? 10. So initially root is null. So what will happen? The node 10 is going to be inserted. Since there are no nodes existed before that, so it will be nothing. Just one simple node it is going to create. Sir, after creating this, what will happen? Since it is a insert operation, you can see after creating this, node is equal to null. That's why a new node got created. Then balancing 1 plus what is the height of the left subtree? Because here left subtree is null, right subtree is null, height is 0 and then 0. Because whenever we are calculating height, already I explained. If node is equal to null, it is going to return 0. So 0 comma 0, maximum is 0. 1 plus, that means, so height is nothing but what? 1 slash, what about balance factor? Height of the left subtree is 0. Height of the right subtree is 0. 0 minus 0, balance factor is nothing but what? 0. So is balance factor is greater than 1? No. Is it less than 1? No. So is it less than minus 1? No. Is it less than greater than less than minus 1? No. So there is no problem. That's why it is successfully inserted. Next, I want to insert one more node. What is that node is 20. So where it will be inserted? So it is a binary search tree only, right? It will compare with root. Sir, is the element is lesser or greater? It is greater. So the position for this is nothing but here. Anyway, for this left child is null, right child is null. After inserting, we have to update the balance factor and height for every node. So what is the height of this node? 1. What is the balance factor? 0. What is the height of this node? 2. What is the balance factor? Sir, 0 minus 1. It
Minus
will become minus 1. So again, the rules and regulations are properly satisfying, hence there is no issue. Now try to insert one more node. What is that node? 30. As per binary search tree rules, where this node should come? Greater than 30. Like that. Now what will happen? We have to adjust height for every. Sir, this left child is null, right child is null. So what is the height? 1. What is the height of this one? 2.
two.
What is the height of this one? 3. Correct? Huh?
Yes.
What is the balance factor for this? 0.
0.
What is the balance factor for this?
1.
0 minus 1. What is the balance factor for this?
-2.
0 minus 1 minus 2. Correct? Huh?
Yes.
Now see, the node which we inserted is nothing but which node? What is the node that we inserted?
30.
30, right? Can I say this one will become node? Correct? Huh?
Yes.
Now observe. After inserting, is balance factor is greater than 1? No.
No.
Is it less than minus 1?
Yes.
Yes. Then check the condition. The data which we inserted. What is the data? 30, right?
Mm.
Is it greater than? the node. What is a node?
30.
30. 30 or 20?
Uh,
We are attached this 30 to 20, right? Yesterday I
yes.
explained. We attached that to 20. Got it? In the
Mhm.
insert function. Where we inserted this 20. Right side to this one. Got it? So after inserting 30, we are attaching to this node dot right. So that means which is node 20, right?
Mhm.
Sir, everyone got the clarity?
No, sir, one second.
See, whenever we are inserting 30, this is the method call, right?
Yes, sir.
Now 30 got inserted. At the time of inserting 30, 30 is the node. Okay.
Okay, sir.
So after inserting, that reference we are assigning to what? Node dot right. We are going for the previous method call. Initially node is what? 10. Correct?
Yes, sir.
Now left side will be there, right side will be there. So left side is null, right side is null. Then if you are inserting any other node, that node will become node. The name of the node is node. But after inserting, we are attaching here, right? How this link is established in the previous method call, this is the node. That node right is equal to whatever operations you are doing. It is a method call. This method call is returning a node, which is nothing but 30. That I am attaching to what? Node dot right. If you are attaching to node dot right, can I say this one is the node? Sir, clear?
Yes.
This point is confusion, sir. Once if you are clear with this, then easily we can. Clear? Yesterday also I explained about this one only. Now see, so balance factor is less than -1. There are two cases. Then what about the data? The data which we are inserting is nothing but 30. Is it greater than node? Sir, node is nothing but what? 20. It's a right side. Again, same data will come, right? Sir, you need to understand one more point. Again, the node will become 10. Okay, don't worry, I will explain. See here, node is what? 30, right? First time node is 30 after inserting 30, correct?
Yes.
When we are inserting 30, these conditions never satisfy because balance factor is 0, right?
Mhm.
When node is pointing to the previous, so we are updating the balance factor every time from the bottom, right? So whenever it came to -1, again these conditions never satisfied. But whenever here we came, then only the node, the balance factor is not satisfied. So
Okay.
if for which node that balance factor is not satisfied, that node name is nothing but the node. Clear?
Mhm. Okay.
Again same principle only, but two times.
Yeah. Yeah.
Now see, these two cases we are verifying now. Balance factor is less than -1. The node is 10. So data is 30. Node dot. Node is 10. What is its right? 20. Its data is 20. Is 30 is greater than 20? Yes.
Yes.
Let me check this one. The data is less than, node is 10. Its left side is null. So this condition will never come. Correct?
Mm.
Clear?
Yes, sir.
Now we are talking about this one. Tell me, is it which case? RR case.
RR. Yeah.
Is correct from the diagram?
Yes.
Clear? Now
Yes, sir.
which method we have to implement?
Left rotation.
So up to this clear means I will write code for left rotation. Clear?
Yes, sir.
Now coming to the left rotation code, it is very difficult to understand. Please focus. Left rotation code I am writing. So how to write left rotation code? Sir, we are passing one node as a parameter. What is that node we are passing? X. Sir, in the programming point of view, which is X in the left rotation? The node, correct? Can I say this is nothing but X? Am I right? Correct? because node is 10. The 10 I am passing as a parameter to left rotation. In left rotation, at the time of receiving, I have given one more name. What is that name? X. Is it
X.
correct, madam, up to this?
Yes, sir. Yes.
Now, I am creating one node. The name of the node is Y. What is its value? X dot right. I am creating one more temporary node called a T. What is its value? Y dot left. Now observe. What is Y? Sir, X dot right. Can I say this one is Y?
Yes.
Y dot left. This one. Can I say this one is a temporary?
Okay. Yeah.
Why I have pointing these three? Because if you do rotation, 20 will become parent, 10 will be there, okay, and 30 will be here. For 30, there won't be any disturbance for children. For X left child also, there is no disturbance. But do you know, this one should come here. Am I right?
Mm. Yes.
So for that, there should be some name, right? For that only I explained this diagram. So RR. Have you observed? We are dealing with this one. For this name, temporary. How to get this one? For this, you should have a name. And for this, already name is there. Based on this, we have to do the rotations. Clear?
Yeah. Yes, sir.
Now observe what will be the code. The first code is y dot left is equal to. Which one we have to write? Sir, what is y here? 20, right? Y is
Yes.
20, right?
Mm.
Correct?
Y is 20. Yes. Yes.
20 left child will become what? In the new diagram, 10.
10.
What is the name of the 10?
X.
Clear?
Yes.
Now, which one will be updated? X right child, correct? Because X right child is previously 20. Now, X right child, we have to update. Tell me X dot right child is equal to, what is the formula? Which one we have to assign right child to 10 in this diagram? Null. Which null? T, right?
T. Yes.
Can I take T?
Yes.
That's all. Nothing, madam. Beyond that, nothing. Clear? Which nodes got affected? X and then Y. Am I right? 10 and 20 got adjusted, right?
Yes.
So we have to update the height of the X. What is the formula? Yesterday we discussed math dot max of. So height of X dot left, comma, height of X dot right. We are updating the heights of which nodes? X and then Y, because these are the two nodes which got affected. Clear? After that, we have to return which reference? We have to return the reference of Y. Sir, why we are returning Y? Because previously X is the node. Now Y should become node, right? Because this is got turned. Clear, madam?
Yeah. Yes.
Now, for right rotation. So forget about this example. I will take right rotation now. Observe. Right rotation means what? First we are inserting 30, then 20 will come. So then 10. So for 10, assume that left child is nothing but a 10L, right child is nothing but a 10R. So here left child is already there, 20R, and right child is nothing but 30R. Actually, these are nulls. So we have to do which rotation? Right rotation, correct? With
Yes.
respect to which node? 30. Can I say this one is Y?
Yes.
Now we have to give the names. Tell me, node X is equal to. Node X is equal to. Which is the X?
20.
Y dot left, correct?
Yes.
This is nothing but X. So can I say this one we have to assign as a temporary? Am I right?
Yeah. Yes.
How to assign? Node temporary is equal to. Node temporary is equal to.
X
What is
dot
that,
right.
madam? Hmm?
X dot right.
I think this one, is it required? Okay, correct. X dot
Right.
right. Am I right? Correct?
Yeah.
Then which one we have to update? So after converting, so 20 will become parent. For this left child is a 10. There is no disturbance for 10L and 10R, correct?
Mm-hmm.
And for 20 right will become 30. There is no disturbance for 30R. Only thing is nothing but what? The 20R will become here. Now
Yes.
tell me the formulas. So I will write left side. Y dot left will become what? Y means which node? 30.
30. Mm.
30 left side will become which one?
X 30 T
Hmm?
T.
T. Correct?
Yes.
Now y dot, ah, better we will write x. X dot right will become what?
Dot right.
X is 20.
Y.
20 right side will become what? Y.
Y.
That's all.
Mm.
Then again what we need to do? These three lines are same, right? Updating the height and returning. Clear?
Yeah. So we have to update only height of X and Y, not all of the nodes height.
Why? Because you can see these two things only got reflected, right?
Mm-hmm.
And anyway, once if you go back, so height will be adjusted automatically.
Okay.
Up to bottom level, we adjusted.
Mm-hmm.
See, 10 height is what here? 1.
One. Yes. Okay. Yeah, got it. Got it. Yes.
Yes, madam, something you are asking. Here, 10 height is nothing but 1, right?
One. Yeah.
There is no disturbance, right?
Yes. Yes. Yes.
Only these two got affected.
Mm-hmm.
That's why we adjusted.
Mm.
Clear?
Yeah.
Huh?
Yes, sir. Clear.
Now, coming back to our old example, 10, 20, 30 we inserted. It should become what? 20, 10, 30. Am I right?
Yes.
Let me execute this program and check if is properly this one got inserted or not. Somewhere there are some errors.
BF, there is no B, right? There is balance factor BF.
Mm, yes, here that's all. And also here also B.
Mm.
Yes. Mm. Unreachable statement. 1 second. I think here in the insert, these are two lines, couple of lines, right?
Mm.
Compulsory curly brackets are required. Correct?
Yes.
Is it came?
Yeah. Yes.
Suppose if it is binary search tree, what is output? 10, 20, 30 in level by level. So for you to understand, I will do one thing. I am creating one more class. Already we have this binary search tree program. Am I right?
Mm-hmm.
So I will take that binary search tree program here. I will name it as a test one. Okay, so I will try to insert a 10, then I will try to insert 20, then I will try to insert 30, and I will show you the output. Now see, test1.java, test1. Are you seeing the difference? The height got adjusted, correct?
Yes.
Now, so even if you are trying to insert 40 and then 50, Okay, and here also try to insert 40 and 50. Now I will execute BST. This is the output. I will execute AVL tree. This is the output.
Okay.
Okay.
Yes.
So now if I am trying to insert 25 here, and if I am trying to insert 25 here, there will be drastic changes. Just you can't understand this very clearly from the output, but if you draw the diagram, you will get a clarity how it will be. Please practice this by taking examples. Okay.
Yes, sir.
So this is nothing but what is AVL tree, how you can able to perform operations on this AVL tree. The only reason to go to AVL tree is nothing but what? For the adjustment of heights.
Right. Yes.
So any doubt up to this, madam?
No, sir.